We've all heard the hype around additive manufacturing, right? 3D printing. It's been called the future of making things, and it makes sense. The idea of printing complex parts on demand with way less waste, it seems like a giant leap for sustainable manufacturing. But what if that's not the whole story? See, when you really start to dig into the entire life cycle of metal 3D printing, things get complicated. That promise of printing with less waste is awesome, but it makes you wonder, what about everything that happens before you even hit the print button?
And here it is. The answer is kind of shocking. For metal 3D printing, up to 50%, and in some cases even more, of the raw material never even makes it to the printer. It's just wasted. That's half the material, half the energy, gone. For a technology that's supposed to be the definition of efficiency, that number is just staggering.
So what is this dirty secret? I mean, if the printing part is so efficient, where is all this waste coming from? Well, it turns out we've all been looking in the wrong place.
The problem isn't the printer, it's the powder. To make 3D printing work, you need this incredibly fine, perfect metal powder. But the current methods for making it, they're really inefficient. It's like trying to make flour and ending up with half flour and half pebbles. That leftover, oversized material either gets used for something less valuable or has to be completely remelted, which costs a fortune in energy. Okay, so that's a huge problem. But, where there's a massive challenge, there's also a massive opportunity. And this problem has kicked off a major coordinated effort across Europe to go in and fix this broken link in the manufacturing chain once and for all. And I mean a major effort. This isn't just some small side project. We're talking about a mission with serious backing from the European Commission's Horizon Europe program. That's their main funding arm for big league research and innovation. It shows they are absolutely serious about solving this. And that mission has a name, REPAM. It stands for Resource Efficient Materials for Additive Manufacturing, and its goal over the next 36 months is, well, it's ambitious. They want to build a completely sustainable circular economy for 3D printing, from the first atom of raw material to the final product, and all the way back again. And to pull this off, they have assembled a European super team. Seriously, this is a 19-partner group that brings together the best of the best. You've got top academic institutions like Sweden's KTH Royal Institute, research giants like Fraunhofer, and huge industry players like Bosch and Turkish Aerospace. It's that mix of brainpower and real-world muscle that makes this project so exciting. So what's the game plan? How is this super team actually going to fix things? Well, REPAM isn't about small tweaks or tiny improvements. No, they are redesigning the entire system from the ground up. And this diagram just lays it out perfectly. Look at this. It's a closed-loop system. They're not just looking at one piece of the puzzle. They're innovating the materials themselves. They're optimizing how the powder is made. They're improving the actual printing. And, this is the crucial part, they're creating brand new ways to recycle waste right back into top-tier material. They're finally closing the loop. All right, let's break it down. Let's start with their first big move, attacking that initial powder waste head-on. The goal here is pretty simple. Make the whole production process way, way smarter. So how do they do that? Basically, they're giving the powder production process a brain. They're using AI to figure out the perfect recipe for the metal before they even start. They're embedding advanced sensors to watch everything as it happens in real time. And they're building digital models to test and perfect the whole thing virtually. It's all about using data to get as much good powder as possible and, you guessed it, cut that waste right at the source. But hey, even with the smartest process in the world, you're always going to have some scrap. So that's where the second big idea comes in, radical recycling, finding completely new ways to get that leftover material back in the game without losing its value. And here is a fantastic example of what that looks like. It's a process they call chips into wires. So instead of taking all those little titanium shavings from machining, what they call swarf, and melting them down, which uses a ton of energy, they do something brilliant. They collect them, clean them, and grind them into tiny granules. Then, using a super advanced laser process, they basically weld those granules together to form a brand new, high-quality wire for 3D printing. It's an incredible shortcut that saves a massive amount of energy. Now, developing all this amazing tech in a lab is one thing, but the whole point of REPAM is to prove that it works out in the real world for major industries that depend on this stuff. And they're on a clock. They have a really clear 36-month roadmap. A year and a half in, the core AI models and sensors are ready. At the 2-year mark, the new manufacturing processes are validated. By month 30, those radical recycling techniques are good to go. And it all leads up to the grand finale at 36 months, the final, real-world demonstrators.
And these aren't just toys. This is the real deal. They're going to produce and test critical parts for 3 massive industries. For aerospace, a structural bulkhead from recycled aluminum, proving it's strong and light enough for flight. For the auto industry, high-performance pistons made from that recycled titanium wire, showing it can handle incredible heat and stress. And for electronics, complex copper cooling parts, showing they can create really intricate, high-performance designs. This is where the rubber really meets the road.
So when you step back and look at the whole picture, what does it all mean? REPAM isn't just about making 3D printing a little bit greener. It's about building a whole new foundation for the future of how we make, well, everything.
I think this quote from the project's own summary just says it all perfectly. Their goal is to put the additive transformation on a sustainable footing and allow Europe to lead the way in this green paradigm shift. It's not just about improving a process, it's about leading a revolution.
And the potential here is just huge. By creating this blueprint for a true circular economy with some of our most advanced metals, REPAM leaves us with a really exciting question. If we can pull this off for tricky materials like titanium, aluminum, and copper, what could be next?